Hi friends, today we will take one examples to discuss the signal transformations, whatever we have studied. Signal transformations, say time reversal, time shifting, time scaling. We will take one example and we will express them mathematically and diagrammatically to have a better understanding on it. Okay, so let's get started with that. Let's take an example, x of t, which is defined between the interval -1 to +1, whose amplitude is 1. So just define x of t. So I know that x of t, it is defined. Instead of saying defined, I know this amplitude is 1. So x of t is 1 for t greater than -1 less than 1, x of t. Now first we will find x of 3t. X of 3t. Wherever you find t, just replace it by 3t. So this is 1, -1 less than 3t less than 1. So this is equal to 1 by 3 less than t less than 1 by 3. So now I can say that x of t, x of 3t, this is equal to 1 for t greater than -1 by 3 less than 1 by 3, and this is equal to 0 otherwise. Why? I know that x of t equal to 1 for t greater than -1 less than 0, and this is equal to 0 otherwise. This is equal to 0 otherwise. Similarly, x of 3t equal to 1, just replace t by 3t, so I'll get x of t equal to 1 for t greater than -1 by 3 less than 1 by 3, and this is 0, and this is equal to 0 otherwise. So I'm just writing it in this way. So now we will plot this x of 3t. We'll plot the signal x of 3t. Plot the signal x of 3t. So I know this x of 3t is defined in the interval -1 by 3 to +1 by 3. This is equal to 1. Okay, so now you can see here, whatever the signal is observed at -1 it's now reflected to -1 by 3. Whatever the signal you find at 1 is now reflected to +1 by 3. So if I do a compression in time, what I get is x of 3t, right? So this is nothing but compression in time domain. Compression in time domain. So this is the first observation. What is the second observation? Without writing this mathematical expressions directly, if I ask you to find x of 3t, all you need to do is divide the x-axis of x of t by 3. Is it dividing? Yes, it's dividing. It's -1 divided by 3, so I get a new timeline here. +1 divided by 3, so I get 1 by 3. So to define a range of values of t for which x of 3t exists, all you need to do is you have to just divide the x-axis of t by this value 3. So -1 divided by 3, I'll get -1 by 3. 1 divided by 3, I'll get 1 by 3. Okay, so this is nothing but x of 3t. Now we will see x of t by 4. I know x of t, this is equal to 1 for t greater than -1 less than 1, and this is equal to 0. This is equal to 0 otherwise. If I ask you to find x of t by 4, If I ask you to find x of t by 4, all you need to do is replace t by t by 4. So I'll just replace t by 4. Wherever I find t, I'll just replace it here by t by 4 less than 1 and 0 otherwise. Okay. So now again I can write this as x of t by 4. This is equal to 1 for t greater than minus 4 less than 4. This is equal to 0 otherwise. Okay. Now we will have a diagrammatical representation of this x of t by 4. This is t. I know that x of t by 4 equal to 1 for t greater than minus 4 less than 4. So this is minus 4, this is plus 4, x of t, this is equal to 1. Whatever I find it at minus 1 now is getting reflected to minus 4. Whatever I find it plus 1 is now getting reflected to 4. Right? So if I expand in time, what I get is this signal. So this is nothing but expansion in time domain. This is the first observation. What is the second observation? If signal x of t is given, if I ask you to find x of t by 4, right? Here all I need to do is just multiply this x-axis, multiply the x-axis of x of t by 4 to get the x-axis of t by 4. Okay. So on the x-axis, I have minus 1, 0. This is 0. This is 1. So multiply the x-axis of x of t by 4. So when I multiply this, minus 1 multiplied by 4, I get minus 4. 0 multiplied by 4, I get 0. 1 multiplied by 4, I get 4. To get a new timeline, or x-axis of x of t by 4, all I need to do is just multiply the x-axis of x of t by 4. This is the second observation. Now we will see x of t plus 4. We will see x of t plus 4. To find x of t plus 4, all I need to do is just replace t by t plus 4. Minus 1 less than t plus 4 less than 1. 0 otherwise. 0 otherwise. So now I can say x of t plus 4, this is equal to 1 for t greater than minus 5 less than minus 3. This is equal to 0 otherwise. Okay, I'm just defining this t plus 4 greater than minus 1 less than 1 as t greater than minus 5 less than minus 3. So now we will define it. Now this signal, we can just write it as x of t minus of minus 4. T minus of minus 4. Right? So now we can see here, I know from this mathematical expression, I can just have a diagrammatical representation of this x of t plus 4 equal to 1 for t greater than minus 5 less than minus 3. So I'm just plotting the signal. What is the observation here? First observation. This signal, it has left shifted by how many units? It's left shifted by 4 units, right? Always, whatever they are asking you to find x of t plus 4, always try to represent it in standard form, that is x of t minus t naught, where t naught here is minus 4, which is less than 0. So this is nothing but left shifting. Left shifting by how many units? Left shifting by 4 units. So When minus 1 left shift by 4 units, what I get is minus 5. When 0 left shift by 4 units, I get minus 4. When 1 left shift by 4 units, I get minus 3. So this is x of t plus 4, right? This is the first observation. Second observation. All I need to do is, once I find t naught equal to minus 4, what I need to do is just add this minus 4 to the x-axis of x of t to get the x-axis of x of t plus 4, right? This is minus 1. I'm adding it minus 4. Minus 4 minus 1, which is nothing but minus 5. 0 minus 4 is nothing but minus 4. 1 minus 4 minus 3. To get a new timeline or to get the x-axis of x of t plus 4, all I need to do is add t naught to x-axis of x of t, which is nothing but minus 1 minus 4 is minus 5, 0 minus 4 is minus 4, 1 minus 4 is minus 3. So this is x of t plus 4. Now we will see x of minus t. Wherever you find t, just replace it by minus t. This is 0. For minus t less than minus 1, then 1, this is 0 otherwise. I can say x of minus t equal to 1. For t greater than minus 1, again it is less than 1, 0 otherwise. As we discussed in the last section, x of minus t is like just folding the signal x of t with respect to y-axis. Now, if I fold the signal x of t with respect to y-axis, this will go this side and this will come this side, right? So now I can just write it as x of minus t. X of minus t as the math. I'm plotting the signal x of minus t. This is minus 1 to plus 1. This is x of t. So this is equal to 1. Okay. I hope this example is clear to understand the signal transformations. We will also take one more example in the next section to understand it more clearly. So if you like this video, please subscribe it and share it with your friends. Thank you.